Bismillah. Another title on SAAT, the conic sections. What are the conic sections? To define for you the conic sections, you need to imagine that you have a cone. Two cones exactly, they're matching each other at this point. And you have a plane. This plane, this gray plane. If you cut the cone from this side, it will give you this shape. This shape is a parabola. But if you cut the cone from this side, it will give you a circle, sorry. And if you cut it with an angle, and if you cut it straight horizontally, it will give you a circle. If you cut it with an angle, it will give you an ellipse. But if you cut the plane into the two cones together, it will give you a hyperbola. It will give you a hyperbola. What do I need to know about the conic sections into the SAAT? You need to know the equation, how to graph it, and how to find the vertices and the foci. Let's go through it, and inshallah you will find it easy. First, let's start with equation of the circle. Equation of the circle is x minus h squared plus y minus k squared is equal r squared. And if you notice, this is the same as the equation of the distance between 2 points. Distance between 2 points, where center of the circle is h and k, and the radius is r. If you have a circle in the coordinate plane, its center is here, and the center is h and k. And you have a point on the circle. This point is x and y. Distance between the point and the center of the circle is the radius. So by applying the rule of the distance, x1 minus x2 squared plus y1 minus y2 squared is equal r squared, you can figure out that the equation of the circle is x minus h squared plus y minus k squared is equal r squared. For example, if you have a circle with center 1 and 2 and radius equal to 5, and you wanted to find the equation of this circle, it's going to be x minus 1 squared plus y minus 2 squared is equal 5 squared, and 5 squared is 25. This is a direct substitution. But I need from your side to notice something very important. If you have a center 0 and 0, in this case, and the radius 5, in this case, the equation is x squared plus y squared is equal to 25. Why is that? Because x minus 0 squared is the same as x squared. So this is called equation of a circle. Equation of a circle. What you need to know that h and k is the center, x and y is a point lies on the circle. Find the center and the exact radius of the circle x minus 5 squared plus y plus 3 squared is equal to 9. So I need to figure out what is the center. I need to figure out what is the radius length. It's clear for me that the center is, I'm going to change the sign of negative 5 to be 5, and I'm going to change the sign of positive 3 to be negative 3. And the radius is equal root of 9, which is equal to 3. If you just wanted to sketch this circle, you will go to the point 5 and negative 3, move to the right 3, radius, up 3, left 3, down 3, join between the point, here is the circle. And we can notice that the x-axis is a tangent to this circle. So center is 5 and negative 3. Don't forget that they changed the sign. If it's negative, become positive. If it's positive, become negative. So the center is 5 and negative 3. The radius is equal to 3. Another example, find the exact length of the radius and the center of the given circle. X plus 3 plus y squared is equal to 25 over 9. So we can notice that in this equation, the center is negative 3. I'm going to change the sign beside the x. And y squared, I don't have any value. It's not in the form of y plus to the power of 2. So it's y plus 0. So the center from the y-axis. Radius is root of 25 over 9, which is equal to 5 over 3. So negative 3 and 0, here is the center. 5 over 3 to the right, 5 over 3 up, 5 over 3 left, 5 over 3 down. Here is a sketch for the circle. Here is a small sketch for the circle. So equation of the circle, and we solve it 2 examples. The second shape in the conic sections is the ellipse. And ellipse is not the same as the circle. Circle is a closed curve equidistant from a point inside it. But the ellipse is a closed curve which is equidistant from 2 points inside it. We called it foci. Notice that foci is the plural of the word focus point. Okay, so here is a graph for an ellipse, and as we notice that we have a long or a major axis, its length is greater than the minor axis, and this axis could be horizontal, so the long side could be horizontal, or the long side could be vertical. So in this case, it's a vertical major axis, but in this case, it's a horizontal major axis. The 2 points at the end of the axis is called vertex. So vertex and vertex, 2 vertices. So major axis, minor axis, 2 vertices, actually 4 if we count these 2. So V1, V2, V3, and V4. And the focus point lies on the major axis. If the horizontal, so F1 and F2 lies on the horizontal. But if it's a vertical, F1 and F2 lies on the vertical axis. Notice that for the second one, the center here is not 0 and 0. Center is not 0 and 0. So we call the center here H and K. The general equation of the ellipse is x squared over a squared plus y squared over b squared is equal to 1. But this ellipse, its center is 0 and 0. But in case of the ellipse, its center is not 0 and 0, h and k. Here is the equation: x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Let's go to the first example for the ellipse. Graph the ellipse and identify the center, vertices, and foci. X squared over 9 plus y squared over 25 is equal to 1. Notice that for the ellipse, the sign here is plus. So we take the number below the x and we figure out its positive and negative root. Positive and negative root of 9 is positive and negative 3. You go to the point 3 and the point negative 3. Center here is 0 and 0. So center 0 and 0. We go to the number below the y and we call it b. It's a positive and negative root of 25, which is positive and negative 5. So we go up 5, we go down 5. We can notice that the major axis is on the y-axis. Then we draw a curve, not a straight line, between these 4 points, which are the vertices. Here is I have, I have the vertices of the ellipse. So vertices of the ellipse: V1, negative 3 and 0, V2, 3 and 0, V3, 0 and 5, V4, 0 and negative 5. Now, where is the foci? I need to figure out the value of the foci. The foci, I'm sure that it lies on the y-axis. So all what I have to do is say that C is equal positive and negative root difference between these two values. So 25 minus 9. So C, which is the foci, is positive and negative root of 16, so it's positive and negative 4. So I go to the point 4, I go to the point negative 4. Here is F1, here is F2. So the first foci is 0 and 4, and the second foci is 0 and negative 4. So here is the major axis is a vertical line. The foci lies on the major axis. Another example for the ellipse. You have an ellipse which its equation not in the form of x squared over a squared plus y square over b square is equal to 1. So I need to rearrange the equation. And to rearrange the equation, I'm going to divide each term by 36. So x squared over 9 after simplifying plus y squared over 4 after simplifying is equal to 1. Now I have equation of an ellipse. Okay, its center 0 and 0. Why? Because it's x squared and y squared. Its vertices, I care about the vertices of the greatest number below. It's below the x-axis. In the last example, it was below the y-axis. So positive and negative root of 9, which is equal positive and negative 3. So the point negative 3 and the point 3 are vertices. So it's negative 3 and 0 and 3 and 0. For the point A. For the point B, it's positive and negative root of 4, which is equal positive and negative 2. So here is 2 and here is 2. Now join between them. Here is the ellipse and here is the major axis. The foci are the 2 points lies on the major axis. So I want to find C. It's positive and negative root difference between 9 and 4. So it's a positive and negative root of 5. So here, root of 5 about 2 point something. Yes, very good. So it's 2 point and 2 point. So here is F1 and here is F2. So F1 is root 5 and 0, and F2 is negative root 5 and 0. Now, go to the third conic sections, which is the parabola. Parabola, as you know, it's a curve open upside down or to the right or to the left according to its equation. And the general equation of the parabola is y squared is equal 4px or x squared is equal 4py. If it's x squared, it's open up and down. If it's y squared, it's open right and left. This equation at the front of you, in case of the center of the parabola, is not 0 and 0. While you draw a parabola, for example, f of x is equal x squared, and this is a parabola, you will notice that there is an axis of symmetry. Divide the parabola into two congruent areas. Okay, and we have line called directrix. What is the directrix? It's a straight line below the parabola, which the parabola will not exceed, like the asymptote line. And the definition of the parabola is a set of points that equidistant from both focus and directrix. What is the focus? Focus in this case is inside the parabola itself. Inside the parabola. Again, we have to form y squared is equal 4px or x squared is equal 4py in case of the center 0 and 0. In case of the center is not 0 and 0, it's x minus h squared, and h, if it's equal to 0, you will not find h. K, if it's equal to 0, you will not find k. So it's a h and k in case of a symmetry. X is equal h is the axis of symmetry. Vertex h and k. Focus point h and k plus b. I will show you how you can figure out all of these without copying the rule in your mind. Okay, so let's go together to the first example. Graph the parabola and identify the vertex, directrix, and the focus. Here is the equation of the parabola. Y squared is equal negative 12x. Y squared is equal negative 12x. So the equation starts with y squared, so it's open to the right or to the left. But the coefficient of x is negative, so it's not open to the right. It's open to the left. Again, from the equation itself, since it's open, since it's y squared, it's open to the right or to the left. Since the coefficient is negative, it's open to the left, not to the right. This is the first. Second, I need to figure out what is the focus point. The center of this parabola is 0 and 0. Why? Because it's not y plus or x plus. So I'm going to write that 4p is equal negative 12. So the value of p is negative 12. So the center of this parabola is negative 3 and 0. So here is the center. Okay, so you need to graph the parabola. But how I would graph the parabola? I would graph the parabola with narrow or wider. It doesn't matter if you're sketching. It doesn't matter if you're sketching. So this is the focus point. Sorry, it's on the center. Center is 0 and 0. The focus point is -3 and 0. What about the directrix? In this case, the directrix is it's equal because it will be below the curve. Negative of p, and p is -3, so it's equal to 3. So you go to 3 and you draw a straight line. This is called directrix. Here is the center, and I will sketch the parabola. So focus point, directrix, and I need to find the vertex. Vertex of this parabola, if it's necessary, you can replace the point 0 and 0 as a vertex, not as a center. So I can say V is the vertex because I don't have two constant points on the parabola as the ellipse. Another example. Graph the parabola and identify the vertex, directrix, and the focus. The parabola here starts with x squared, and since it starts with x squared, it's open up or down, and its vertex is equal to 0 and 0. So the vertex is 0 and 0. 4p is equal to 8, and since it's 8 and 8 is a positive number, so it's open upward. So this example could be x squared equal -8y. Will open downward. Now I'm looking for the directrix, I'm looking for the focus. So the value of p is equal to 2. So directrix is y equal -p. So y is equal -2. So I go to the point -2 and I draw a straight line. This is straight line is y is equal -2. This is the directrix. Okay. Now the focus point is 0 and p. So it's 0 and 2. So here is 0 and 2, the focus point. Vertex is 0 and 0. And now let's sketch the parabola. Okay. What if I wanted to find two accurate points to sketch it well? You can replace x with 2. 2 by 8 is 16, and 16 is 4, so it's a point 2 and 4, and the point 2 and -2 and 4. So the parabola is more narrow, not wider. It's more narrow. But as I said, it's a sketching of the parabola. And notice that in SAAT, you don't have a graph. I'm just trying to guide you. And we have a whole lesson on my channel on YouTube for how to solve the parabola with all the cases. But the case at the front of you is the one you need to understand in your SAAT journey, inshallah. Now, let's go to the hyperbola. Hyperbola is the fourth conic sections, and it comes when a plane intersects the two cones. So as we can see here, I have two parabola. So this is called hyperbola, not hyperbola, hyperbola. Okay, this hyperbola have a line in the middle, which the two parabolas are equidistant from it, have a line of symmetry, and have asymptotes. The equation or the general equation of the hyperbola is the same as the equation of the ellipse, except that the equation, the sign between the coefficients are negative. I need to understand something. If it's the greatest number below the x and the hyperbola starts with x, the hyperbola is up and down. But if the hyperbola starts with y, even if the small number is here, the hyperbola is open to the right and left. Again, according to the start number width. In the ellipse, we are looking for the major axis and minor axis. But in the hyperbola, we are looking for which coefficient the hyperbola starts with. If it starts with x squared, it's open up and down. If it starts with y squared, it's open to the right and open to the left. Here is at the front of you, if the equation of the hyperbola, it's a case or in case of its center is not 0. Okay, it's not generally come in your tahsili, but at least you know how to translate. So you can use translation while you are solving the hyperbola. By using the example, I'm going to show you how to figure out all of these equations, center, vertices, foci, and the equation of axis of symmetry or line of asymptote without copying the rule in your mind. Let's start with the first example. Graph the hyperbola and identify the center, vertices, slope, and the focus point. Y squared over 9 minus x squared over 16 is equal to 1. Notice that the hyperbola is negative. So hyperbola is negative. Start with y squared, so it's open to the right and to the left. Sorry, open. Yes, open to the right, open up and down. If it's y squared, if it's x squared, it's open to the right or to the left. Again, if it starts with y squared, up and down. If it starts with x squared, it's open to the right or to the left. So I made a mistake here when I said that if it starts with x squared, it's up and down. No. If it starts with x squared, it's right and left. And if it starts with y squared, it's open up and down. Up and down. I did a mistake. Teachers even do mistakes. Okay. So let's start. I will go and take the roots below the point x, so I can say that the root of the point b in this case is positive and negative root of 9. So positive and negative 3. So I go to the point 3 and the point negative 3. And the point below the x is 4 and negative 4. In case of ellipse, you were joining between them. But in case of parabola, you draw a parabola that passes through this point and pass it through this point. So this is the vertices. Okay. Now, what about these 2 points? These 2 points, to figure out if you join between them and form a rectangle, and you draw the diagonals of the rectangle, this line is called the asymptote. And the whole parabola should be inside this asymptote. And you cannot graph a parabola here and you draw like this, parabola outside the asymptote. So the center is 0 and 0. Vertices is 0 and 3, 0 and negative 3. Why? Because I start with y-axis. Now let's go to the foci. In case of the ellipse, we were saying that c is equal positive and negative root, the difference between these two numbers. But in case of hyperbola, it's the sum of these two numbers. So it's positive and negative root of 25. So it's positive and negative 5. And notice that the foci is inside the hyperbola itself. So f1 and f2. So it's 0 and 5, 0 and negative. Regarding the asymptote, you wanted to find the equation of a straight line that passing through the origin. So y is equal. The straight line is positive and negative because it's actually 2 straight lines, so positive and negative. Any slope is rise over run. I raised 3, I ran 4. So it's 3 over 4 in terms of x. So I figure out for you center, vertex, foci, and asymptote of hyperbola that open up and down. Let's go to another example to show you how we can figure out the slope of asymptote, equation of asymptote versus center of this hyperbola. But notice that this hyperbola is not arranged in the form of x squared over a squared minus, y squared over b squared is equal to 1. So I will divide it the whole 3 terms by 16. So x squared over 4 minus y squared over 16 is equal to 1. So the point A, which is positive and negative root, the number below the x-axis. The point B, which is positive and negative root, the number below the y-axis. So the point A is 2 and negative. Since this hyperbola starts with x, so it's open to the right and to the left. Its center is 0 and 0 because it's not x plus or y plus. So the point 4 and negative 4, and I'm going to draw the hyperbola. First, I can start by the line of asymptote by drawing the rectangle. Here is the line of asymptote. So the hyperbola is here. and O. Vertices are the point 2 and 0, negative 2 and 0. But what about the focus point or the foci, the 2 points? C is equal positive and negative root. If this sign is minus, you are subtracting the two numbers. No, you are adding the two numbers. This is a common mistake. If it's a plus in the ellipse, you are subtracting the number. But if it's minus, you are adding the number. So 16 plus 4, which is equal positive and negative root 20. Root 20 is positive and negative 2 root 5, which is approximately 4 point something. So here is the first F1, and here is the second focus point. So the focus point is 2 root 5 and 0 and negative 2 root 5 and 0. Last thing is the asymptote. How I can write the asymptote, the equation of the asymptote? As we can see, this straight line is passing through the origin. So y is equal positive and negative mx. So y is equal positive and negative. The slope is rise over run. I raised 4, I ran 2x. So it's equal positive and negative 2x. So here is the equation of the asymptote. This is all what you need to know about the hyperbola. Now I'm going to do some questions related to the tajma'at for the hyperbola or the conic sections.